Hello, this is the proposal of our project on identifying lung infections and predicting their severity using chest X-ray datasets. Our team includes Advait, Saurish, Dongbok, Sankalp, and Swasti. In the wake of the COVID-19 pandemic, correct identification of infections and predicting their severity has become very crucial. Commonly used PCR tests are good for identifying infections. However, predicting their severity is out of the scope of these tests. On the other hand, chest X-rays have proven to be a great source to accomplish both these tasks. Towards this, our project aims at developing a machine learning framework that can identify infection types as well as predict their severity. In this project, we are going to use two datasets, namely the chest X-ray dataset and radiography dataset, which contains chest X-ray images of the patients with COVID-19, pneumonia, and other infections. The images are annotated with the type of the infection as well as their severity in terms of the spread as well as the amount. We aim to address several dataset specific and task specific challenges in this project. Since medical data is hard to obtain given ethical and privacy concerns, these challenges mainly include class imbalance, distribution shift, sampling bias, and scarcity of annotated data, especially for severity prediction. Also, it is extremely important that our model predicts as less false negatives as possible. Although the existing literature is full of works that target the classification of infections, predicting their severity is severely unexplored. Also, extending the analysis beyond one dataset is rarely seen in the current literature. In this work, we also aim to emphasize more on avoiding certain types of misclassifications that might be fatal if deployed in real world. Finally, we aim to explore self-supervised learning, which is relatively unexplored when it comes to analyzing infections. In this project, the first task is to obtain baseline results using traditional classifiers. Then, to improve these baselines, we plan to design and implement a deep convolutional neural network with customized loss function and architecture. To assess this framework, we plan to incorporate two unsupervised techniques. Firstly, we plan to append a clustering-based ROI extractor before the classifier to improve its performance. Secondly, we aim to implement pre-text tasks and contrastive learning-based self-supervised modules to perform unsupervised pre-training. Our potential results include an ML-based framework for high accuracy prediction of infections along with their severity. In addition to developing this framework, we also plan to obtain benchmarks for various tasks like transfer learning and self-supervised learning on the selected dataset. This is the proposed timeline of our project, and this is the distribution of responsibilities among the team members.